Hello, everybody. This is Mr. Bowman. Today we're going to be looking at the ALEX topic, simplifying a higher order radical expression, univariate. So a couple things to clarify before we jump in here. Higher order just means we're not going to be doing square roots anymore. We're going to have an index that is greater than 2. And univariate just means we're using a single variable, as opposed to multivariate, which means we're using more than one. If you do have a multivariate problem, it doesn't really change all that much. It just means you have an additional step, or not really step, additional process with the next variable. So you would just take what we do with this v here, but you would do it again separately for each variable you have. So if you have w's or x's or whatever the case may be, you'll just repeat this step we do with the v more than once. So just like when we had square roots, though, I'm going to take this 96 and I'm going to make a factor tree and try and find that prime factorization of 96. So let's go ahead and do that. So we got 96, and it is even, so we can always just start with that and say it's 2 times 48. And I'm just going to keep dividing by 2. So 2 and 24, 2 and 12, 2 and 6, which goes to 2 and 3, which are both prime. So the end of all of my branches are prime. So I end up with 96, which equals 2 times 2 times 2 times 2 times 2 times 3. So 1, 2, 3, 4, 5, 6 numbers. Yep. And you can always double check to make sure you did this correctly, or make sure you don't forget any numbers if you need to, by just multiplying these together. So 2 times 2 times 2 times 2 times 2 times 3, which should end up at 96, right? Which it does, and just went ahead and check that quickly. And then we have v to the 8th. If we have a large number here, you don't have to do this step. You could divide and find your remainder. But since there's only 8, I'm going to go ahead and write them out. So v, 5, 6, 7, 8. All right, so remember, this index number tells us how large of a matching group we're looking for. So I need 5 matching things to circle it and make it into a single group. So here I have 2, 2, 2, 2, 2. So I have 5 2s. So that's a single group. I have 1 3, so that's not even close. And I have 1, 2, 3, 4, 5, 6, 7, 8 V's. So I can circle 5 of them. So 1, 2, 3, 4, 5. And it doesn't matter which ones, really. So that's a group of 5 V's, and I have 3 left over. So when I write this out, first off, be very, very careful to make sure you actually put the index back in. So it's still a 5th root. So don't just write a square root symbol by not putting a number. Make sure you bring that index over, and it's not going to change. And then you're going to bring out a representative of each of these circled groups. So I have a 2 here and a V here. And those are going to go out front, so 2v, and they are multiplied together. And then anything not circled is going to be multiplied together and put on the inside. So 3 times v times v times v is 3v cubed. Okay, and that is the simplified version. Now, if you had a larger number like 81 or something instead of 8, what you would do here is you would divide. And so say if it was actually 81, you would do 81 divided by 5, and you get 16.2. So the 16 would tell you this number out here, that whole number, and then the decimal would be your remainder. So 0.2 is 1/5, so it would be 1 here. Or in this case, 8 divided by 5 is 1.6. So that's why we pulled out v to the first. I know it kind of looks like the 5th. Remember, that's the index. V to the first, so it's 1.6, which converts to 1 and 3/5 as a fraction. So that 1 is the exponent here, and that 3 is the leftover v exponent there. Okay. So if you do have a large number, you can also use that trick as well, as opposed to writing them all out.